Hi everyone! Welcome back to another Planetarium live stream. My name is Jessica. I am the director of the Planetarium, and with me I have one of my students, Eli, who I'll let introduce himself.
Hi, I'm Eli. I'm a physics and astronomy student at UMD.
So tonight we've got another fun show for you, all about the Star Wars universe. Eli has been working on a brand new show for the Planetarium called Star Wars Fact or Fiction. And so we wanted to show everyone a little bit of that and kind of give you a teaser of what to look forward to once the planetarium can open back up. So with that said, I will go ahead and turn it over to Eli.
Okay, give me just a moment to get my screen
Yep.
sharing figured out. Um, okay, am I on the right
Yep, you're all good.
window? Okay, cool, awesome. All right, so Star Wars fact or fiction. So we're just going to talk about some things from the Star Wars universe and analyze how they play out in the real universe, or rather this galaxy far, far away from theirs. And kind of notice some differences and similarities or see what's possible and what's not possible. So the first one is binary systems. So we all know this super famous scene from A New Hope where Luke walks out and watches the double sunset with the epic rising music. I think it's one of the best like cinematic and musical scenes in the whole series. It's really awesome. And this is totally legit, actually. So having two suns in the sky means that Tatooine orbits a binary star. It's a planet in a binary system. And these binary stars exist everywhere as far as we can see in our universe. And we even believe that up to 85% of known star systems could be binary. And then many are actually ternary and quaternary, which would be 3 stars or 4 stars. And, I don't know. I haven't seen any numbers on anything higher, but I would say with how big things are, it's probably not impossible that there are some even higher than that.
I've
Maybe
I've
Jessica knows more.
seen one with six.
Yeah,
There is a
that's
known planet found in a six-star system.
yeah. So there you go. So yeah, these multiple star systems are not uncommon. Like I said, 85% of star systems are believed to be binary. So actually, it would probably be more likely for a planet like Tatooine to orbit a binary star than a single star like the Earth. Kind of an interesting way to think about it. Okay, next, we'll talk about habitable zones. So the habitable zone around a star is the range of, or the distance at which a planet could orbit the star, where it would have conditions necessary to harbor life as we know it. Most importantly, that means having liquid water on the surface, and also having like a decent atmosphere, decent temperatures. But that kind of plays into the water. You need certain temperatures for liquid water, certain pressures. So this is obviously assuming that all extraterrestrial life would share the requirements of life on Earth, which we don't know for sure. But we have no better guess as to what life needs than what we can see here, because we haven't found life anywhere else. So, assuming that all extraterrestrial life needs Earth like conditions, we can kind of put a range around a star where planets could be to support life. So, we see this kind of idea in Star Wars. They don't talk about it specifically, but we kind of see it play out. We see it if we talk about Tatooine, Andor, and Hoth. So Tatooine, we know, is really hot, very dry, but we know that there's moisture on the planet because we know that Luke's aunt and uncle own a moisture farm, which they pull out from underground. So there's moisture there. It is obviously habitable because we see people and animals there, but it doesn't look the most comfortable and cool. So we would put Tatooine kind of right on the border of habitable and inhabitable on the closer range to the star, where it's going to be hotter. Endor, which actually isn't a planet, Endor is a moon. But if it were to be a planet, and it would also, even if it is a moon, it needs to still be in that habitable zone. Kind of looks perfect. It's a lush, densely forested planet that harbors a lot of life. I guess the same could be said for Dagobah, which is the world where Yoda lives in his hut. It's very swampy, again, lush, forested. That would be right in the middle of the habitable zone. Perfect temperatures. We see a lot of water, swamps, stuff like that, trees, plant life, which all needs liquid water. So Endor would be kind of right smack dab in the middle of that habitable zone. And then we also see Hoth, which is kind of on the other edge of extremes from Tatooine. Really cold world. Most of its water is frozen. Well, all of it that we see. But seeing that there's life there, we can assume that either there is some liquid water or they figured out a way to melt it. And like I said, it still hosts life, so it's habitable, but kind of right on the other edge. Um, so yeah, so we know from there that the bigger a star gets and the hotter a star gets, the farther away its habitable zone is going to be, just to maintain that liquid water necessity. This one is one of my personal favorites, actually. So this picture right here is a comparison between Saturn's innermost moon, which is called Mimas, and the Death Star. So Mimas, this moon, was discovered in 1789 by astronomer and physicist William Herschel, but we actually didn't really know what it looked like until 1980. So that crater that greatly resembles the I believe it's called the super laser on the Death Star, was discovered in 1980, which is coincidentally 3 years after the first Star Wars movie was released. So I think that's really interesting that astronomers, who I would say there might be an uncanny correlation between being an astronomer and being a sci-fi nerd. I can say that is certainly true for myself with my interest in astronomy and my sci-fi nerding.
Pretty sure that's true for all of us in the planetarium.
Yeah, for sure. Yep. Most of our meetings are more movie discussion meetings than like actually scheduled meetings to get things done. Or at least they
Not
end up
supposed to tell
turning
our
that way.
secrets.
Yeah, they turn out that way. They're not supposed to. But yeah, I just think it's really funny that these astronomers, fresh off the hype of Star Wars, found this moon that looked exactly like the Death Star. And the other really interesting thing about it is that the crater on Mimas, which is called Herschel after its discoverer William Herschel, it emits a lot of like oddly intense heat signatures, much like a super laser would. But they believe that's just because since it's a crater, it's deeper, it's closer to the core, which might be geologically active and have heat convection. But if we look at it in infrared, it's much, much hotter than the surface. So I think that's interesting. Okay, now we will go on to blaster weapons. This is another one of my favorite things to talk about because it's got that kind of a cool science thing. So blaster weapons, which are commonly mistaken as lasers, and I actually didn't know that they weren't lasers until recently, actually fire, and this is a direct quote from the Star Wars wiki called the Wikipedia, which I also like a lot, is called they fire bolts of intense plasma energy converted from energy-rich gas. And while that may sound entirely like a work of science fiction, it's super possible and is already done actually pretty frequently. So plasma is a state of matter just like a gas, except the electrons aren't bound to the atoms; they're kind of free flowing around them. And So that plasma is not something only in science fiction. That's a very real thing that we see mostly in stars. Also, like lightning is plasma. But the bolts we see here are called plasmoids, which are just kind of globs of plasma held in shape by electric and magnetic fields. And actually, blaster bolts have been achieved in very small increments of time and in very small sizes, but they are super possible. They're called spheromax, and the way they work is when they exit the gun or whatever's shooting them. It's not actually a gun in what is regularly done. It's in a lab. But the shape of the moving electrons actually generates an electric field as it goes forward, which keeps it in shape. So it's this kind of self-propagating thing. And it can actually travel like pretty appreciable distances really fast. So their lifetimes are only like hundreds of microseconds. But at the speeds that they're traveling, that would be absolutely plenty of time for a bolt to reach its target. And these bolts are super hot, like multiple thousands of times the temperature of the surface of the sun. So they could certainly do damage to whatever they hit. So while the typical like Star Wars blaster might be significantly out of reach, the ideas behind it are totally possible, and through the magic of engineering and physics, could be a reality sometime in the future. So I
Not gonna
think
lie,
that's really
that's
cool.
slightly terrifying.
Yeah, for sure. It's really scary, actually. I hope it doesn't become a thing, but if it did, I would probably want to buy one. Um, all right. So the next thing I want to talk about is what space flight would look like in the real
We just
world.
got a question real quick.
Yeah.
Do scientists have better aim than stormtroopers?
That's a good question. Maybe one for an experiment. We just need to find stormtroopers as a sample size.
We'll gather some up, do some testing, let you know.
Yeah, I totally volunteer to be the sample size for the scientists if I qualify. So okay, so on to spaceflight in the real universe versus the Star Wars universe and all of science fiction, pretty much. So in like science fiction and Star Wars specifically, we see very few differences between what spaceflight looks like in space, or what flight, I should say, looks like in space versus what flight looks like in an atmosphere. When in reality, they're totally different things. Namely, because in an atmosphere, a spaceship has forces working with it to affect where it's moving, namely the gravity force pulling it towards whatever it's going around, and the lift force created by the air that it is flying through. And then the lift force, when the plane turns into a centripetal force. So that's how they turn. So the image on the left here shows a diagram of the forces acting on a plane as it flies through an atmosphere. So we have the weight pulling it down, and then we have the lift force pulling it up. But then if it were to lean to the side, that lift force all of a sudden moves to the side with it, which then, when you look at the sum of the force's parts, ends up pushing it to the side. So when planes that we fly in on Earth turn, they are actually just tilting, and then that tilt makes it follow a circular path that turns it. And that is kind of like the basis of flight on Earth. But it's totally different in space because you have, assuming you're not near anything, you have no gravity. And then assuming there's no air in space, which there isn't in our universe, well, there's not air as we know. There's stuff there, but not enough to make a change. It isn't going to have a lift force. So that totally changes everything. So here, this is kind of a ragtag image that I put together just to try to get a point across. So if we wanted the Millennium Falcon here to move to the right in the direction of the red arrow pointing out of its front, we would need to engage a thruster pushing it forward, and that thruster would be in the back, which is the yellow arrow pointing to the left. So that's simple enough. We can definitely do that. But then what happens if we want to move up and to the right? Now we have to engage two thrusters. We have to have one pushing it forward and then one pushing it up, which is going to create motion in that diagonal path in the direction of the green arrow. So spaceflight in space is going to be much more complicated than it is going to be on Earth. And science fiction does a lot of injustices for this, and it doesn't depict it very well, but with good reason, because it would be really messy to depict it that way. And that's just not really how we fly stuff in space right now. So like those videos of the Millennium Falcon, like bobbing and weaving through an asteroid field, like that's just not really the reality of spaceflight at the moment. More so, we just send something out there and then let it drift to wherever it's going, with very occasional boosts or adjustments to its path. And luckily, it doesn't have to dodge anything like asteroid fields that we see in Star Wars, because the asteroid fields that we see in Star Wars are super unrealistic. But we'll talk about that a bit. So
you would
next,
need, I guess, a minimum of 6 rockets then, right? Top,
yeah,
bottom, front, forwards, backwards, left, right?
yeah, yeah. But then as I was thinking about that too, I got frustrated because even if you're doing that, your motion isn't going to be like, you're not going to be able to turn. You're just going to like move up and diagonally. Like you're not going to be able to change
Oh
the
yeah,
direction
you'd
the
have to
spaceship is
have
going.
something to make you spin
Right,
and turn.
exactly. So like an off center thing. So you'd need a lot, and it would just be really inconvenient. So I think at least for the time being, we're going to stick with the ships or the spaceships that we are looking
Or
at.
have
Just kind of.
or have thrusters that you could change the angle of.
Oh yeah, you could do that. Yeah, I suppose that would create some spin. Yeah, that would be easier. Probably better than what I was envisioning. When I was making the video for the actual planetarium show, I was trying to like Photoshop and like After Effects in one with one that spins it and then one that moves it, and it just became really frustrating really fast. So
I
I
bet.
can only imagine what it would be like to build that. So okay, so this is another thing, not incorrect, but something that just kind of always grabbed my attention, is that if you ever look at the like flying scenes, all of the spaceships are oriented the same way, like up and down. Now this one it kind of makes sense because they're around a planet. This image is over Coruscant right now, but like if they're all in space, like we often see Imperial Star Destroyers in space, all in the same orientation, and that doesn't really make sense because like there's no defined up or down, and more likely than not they launch from planets that were at different angles and tilts and things like that, so they would all be at different angles and like different orientations, but they never are. And obviously that just makes it easier for the viewers to like get a sense of what's going on. But I always thought that was not always, I should say, when I started actually knowing stuff about astronomy and that and that stuff, I it just kind of jumped out at me that it would never look like that. But again, not inaccurate or impossible, just unlikely. Um, so next, okay, this is the asteroid fields bit that I wanted to talk about. Like I said, Star Wars asteroid fields are super unrealistic. So one of the other planetarium workers knows a number, and that's the average distance between asteroids, like even in a densely populated area like the asteroid belt. I don't know that number by heart, but I do know the probability of like a space probe going through the asteroid belt colliding with something, and it is a less than 1 in a billion chance. So if we were to send a space probe right through the thick of the asteroid belt, it still has a less than a 1 in a billion chance of hitting something. And multiple probes and spacecraft have traversed that without even seeing or imaging an asteroid.
Yeah,
So
I don't know the distance, but I do know the statistic that if you were to stand on an asteroid, it would be months or even years before you even saw another asteroid. That's how
yeah,
far apart they are.
yeah. So not really anything you have to worry about. I would say probably the biggest danger, more realistically, would be like moving through the rings of a planet. And even though usually the rings of the planets are super like made up of super small particles, I would say that's probably the area where you could run into the most trouble. I don't know, maybe just better.
Yeah, those are definitely they're everything is much closer together. It's
Right,
more like what you see in asteroid fields in movies.
right.
That's more like a ring around a
Hmm.
planet rather than an actual asteroid belt.
But then the easy thing about the ring of a planet is you just fly around it because
Yep.
it's really thin. So, but again, I'm not going to argue with it. So next, this is another favorite of mine. This is the waves in space section. Now this video, if you're a big Star Wars fanatic like myself, you can probably hear this video in your head. So this is as Obi-Wan Kenobi is flying to Geonosis in Attack of the Clones to get a lay of the land of how they're producing the droids that they're making. And he's being pursued by Boba and Jango Fett in their spaceship. And their spaceship has a seismic charge. And the seismic charge releases from the ship and then flies towards Obi-Wan's ship and then detonates and causes this like huge like seismic wave. Except the only problem is that since there's nothing in space for that wave to travel through, it wouldn't be there. Because a seismic wave is a wave that travels through a medium. In the Earth's case, it's like the Earth's crust. So when an earthquake happens, it's literally Earth's crust is like a wave, and that wave is propagating, and that's what you feel when you're moving in an earthquake. I've never experienced one myself, but that's the idea behind it. Um, and also like sound in space, another wave, you need a medium for it to travel through, and since there's no medium in space for it to travel through, you wouldn't hear anything. So that's just kind of an interesting little thing to look at. I was always wondering when I was talking about this was like, if I were to, like, if you were to make a seismic charge and put a bunch of stuff in the thing and then let that stuff go out and then detonate it, would it work as the stuff moved outwards? But then that's just like more of like a shrapnel grenade rather than like a wave. So I don't know.
Yeah,
Um,
there's math behind it.
yeah,
As far as like how densely packed, how close things have to be together in order to experience a wave like that.
yeah, and that is math that I do not know and do not want to do. So
Oh, you'll have to
uh,
do it eventually.
yeah, unfortunately. Um, all right, this is another cool one in my opinion, but all of this is cool to me because I like Star Wars. Um, so traveling through space is no easy task, and we know this very well from our own endeavors going into space. But it would be even more of a not easy task in the Star Wars galaxy, where you're traveling from planet to planet. So let's just think about it. The fastest speed reached by a man-made object was 153,454 miles per hour by the Parker Solar Space Probe. That's a mind-blowing number, and I can't even begin to imagine what that is like. But even traveling at that speed, getting from Earth to Mars would take 40 days. So traveling the fastest we've ever made a spacecraft go between Earth and Mars, which are not the closest planets in the solar system, but Mars is one of the closest planets, would still take 40 days. So, if we wanted to go from one planet to another on the other side of the galaxy, a common example of this would be the journey from Tatooine to Ilum, where Jedi younglings would go to complete trials and harvest the Kyber crystal to power their lightsaber. That would take 462 billion years, traveling at 153,454 miles per hour, which is just about 33 times large, or 33 times the age of the universe. So quite some time to make that trek. Luckily, Star Wars created a loophole, and that loophole is called hyperspace. So, in order for ships to travel these great distances in short amount of times that aren't, you know, on the order of millions of times the average human lifespan, they enter a dimension called hyperspace, and it's pretty much uh, like the best way I could think about it is like it's like a wind tunnel. So like rather than walking, these trips or these ships enter this wind tunnel and open a sail that pulls them way faster than they could walk. But it's described as another dimension, which is kind of missing the point of what a dimension is. But for the sake of science fiction, we won't touch on that right now. The only thing that makes it difficult is that the faster an object travels, the harder it is to accelerate that object to higher speeds. So as you get closer to the speed of light, it becomes harder and harder and harder to accelerate it, and eventually becomes impossible. But it's said that these ships that travel in hyperspace are going faster than the speed of light, so that we have obviously problems there. Um, Lindsay brought to my attention, another planetarium worker, that rather than launch from low speeds to light speed very quickly, you'd need to gradually increase because the inertia that you would the quick change that you would experience, the acceleration would probably kill you if you jumped fast enough. You would shrink or get compressed by your own inertia, and that's why in the Star Trek universe they have inertial dampeners, which don't exist in the real universe. But you would need either something that does dampen that inertia, or you would need to gradually increase your speed rather than make a jump, or else you would die. So
Yeah, it's like the difference between very gradually stepping on the gas pedal and all of a sudden stepping on it, that jolt you feel when you suddenly lurch forward. It's that, but times like a lot.
yeah, times deadly amount. So okay. Oh yeah, another Kessel Run. One thing Star Wars did get right, and this makes me really happy, despite the widespread belief that it's wrong, was the famous Han Solo line: "The Millennium Falcon made the Kessel Run in 12 parsecs." Try saying that 3 times fast. At first, it sounds like Han said it made this drive in this distance, which would be like saying I drove from Duluth to Minneapolis in 5 miles. Like that doesn't make sense. because a parsec is a unit of distance equal to, I believe it's 3.16 light years.
3.26.
Trust Jessica more than me. Obviously, that sounds super wrong, but he's actually, it's total fact. It makes sense. The Kessel Run is a really dangerous region of space that's populated by a bunch of junk and like space debris and a couple black holes here or there. And usually, in order to traverse it, you'd need to take this long blue path that I'm outlining, this kind of blue line, traditional Kessel Run route in the legend at the bottom. But in order to get through it really quick, Han Solo traveled in the Millennium Falcon through the risky record-breaking run that you see in the legend. And he was only able to do that because his ship travels super fast. So he had to bob and weave throughout black holes. And you couldn't do that if your ship was slow because the black hole's acceleration of pulling you towards it would outweigh your speed's acceleration or your ship's acceleration in the other direction. But what Han was saying is my ship is so fast that I was able to just fly right past those black holes rather than take the long way out. So it's a totally valid thing for him to say. And basically, it just illustrates the point that his ship can really haul its way through a bunch of black holes.
Okay, see, now I have to know, as an outsider, not super into Star Wars, but have heard this before, was this actually the real meaning behind it originally, or did someone be like, George Lucas, you messed up, and he ended up coming up with an explanation?
I don't know. I don't know. Yeah, I don't know. I shouldn't say anything. I have no idea. I would like to think that it was the former, but it's probably very possibly the latter. But I do think it's cool that they brought in stuff like parsecs, and I don't know. I just think it's a really
and
cool.
the explanation they came up with, even if it was after the fact, is still really cool.
Yeah, it's awesome. And then they remade the scene in the new Solo movie, which I have yet to see. But yeah, I should probably watch that because I bet it's just the coolest scene ever. Okay, finally, we're at lightsabers. So while lightsabers is probably the coolest thing I've ever seen in my whole life, they don't really work out in the way that we'd hope they would. And people have tried. They have tried very valiantly. So lightsabers would most likely be constructed in the same way that these blaster bolts are, with these arrangements of plasma that stay in place because of electromagnetic fields. But there are a couple problems that come into play. The energy, first off, required to consistently heat the plasma and then generate a field that keeps it in place is like way more than can be stored in a lightsaber hilt. Like we're talking like probably like a room size generator to power, it maybe to half capacity. It's just totally like I can't even put a number on it because it's just way impossible. But also there would be no way to stop the plasma at the end of the saber, which is also a bummer. So at that point, you just kind of have a laser pointer, but a really hot one that really hurts people. And I mean, you could think of a solution like putting a mirror at the end, but then if you put a mirror at the end, it's coming back at you, which you also don't want, and then it'll ruin your lightsaber hilt. So there's really not a good way to go about it. The other thing is cooling the hilt. So that would take a lot more energy and space than is available as well. You'd need to have like a million refrigerators there to do that. And also the battle constraints are completely devastating. So since the plasma is extremely light, and it's just the hilt would be so much heavier, the weight balance would be all in the hilt, and that would make it really hard to wield as a weapon. And also, due to the fact that the plasma isn't solid, you'd get none of like the cool collisions or like noises as they hit each other, and they'd just pass right through each other. So it would be a big bummer, and it wouldn't really look as we wanted. It'd probably be pretty easy to win a lightsaber fight, and lose a lightsaber fight for that matter. So I don't want to end on a bummer note though. So the coolest thing that maybe I've ever seen in real life, and the closest thing that's ever been made to a lightsaber, is called the Proto Saber, and that's actually a canon Star Wars item, but it was remade by a popular YouTube engineer. His channel name is the Hacksmith. Now this is not a super kid-oriented channel, but if you want to check it out, you can do that. I'm not going to link the video here, but if it is appropriate for you, go ahead and check out the video. It's really cool. So he takes this, he makes a battery pack, and he makes it look really cool with like copper washing and stuff. And in that battery, he has 20 kilowatts of power in there, and he sends that power through a tungsten blade that is held in by a lightsaber hilt, and that tungsten blade heats up to red hot, which is about 3,000 degrees Fahrenheit, and that's hot enough to cut a lot of materials, as you can see in the video, and it's definitely the closest thing we have to a working lightsaber at this point. So hopefully I can get one of those at some point, but they also make them more safe than they are in the video, because I would most definitely hurt myself. And those become like a leisure item, because I really want one. But it was very expensive to make, so I don't think that's in our future anytime soon. Okay, with that, I'm going to end my sharing and come back to, yeah, okay, cool.
Very awesome. Well, if anyone has any questions, now is a great time to leave them in the comments. While we give that a minute or so to see if any more questions come in. First off, great job, Eli. I know he's worked really hard this summer to put this program together, and I can't wait till we can have everyone back at the planetarium to actually see the full dome experience of this show.
I pretty much learned how to video edit and like do stuff like that, so I could do it. I'm really excited to see how
it's going to be awesome
on the big screen.
And it's definitely a much needed revision to the Star Wars show we used to have. Mm-hmm. But I also want to let people know, if you don't already, that we do have a couple of virtual summer camps that we're offering this month. Registration is open through Friday for our 2 summer camps. You can find the link to our webpage with information in the description for this video. But basically, we're doing these virtual summer camps where we'll meet with our campers online, and all of the campers will get a box of activity supplies so that they can do all sorts of fun at-home stuff guided by Planetarium staff. And we're really excited. We've put a lot of work into these, and so yeah, we're excited for this.
Yeah.
But bringing it back over, I'm not seeing anything else come in. So I guess we will start to wrap it up. Thank you everyone so much for joining us. In the upcoming week, on Saturday, we're going to be doing our new monthly, or I guess the July version of our Constellation Storytime. Since we have a new month, there's some new stars and new constellations that can be seen. And then next week, Lindsay is going to be teaching us all about the history of spaceflight. So all of these really incredible women who helped launch us into space. And then next Saturday, I'm forgetting what we're doing. What are we doing, Eli?
Next Saturday?
Yeah.
Let me check.
I've blanked on what we're doing. Oh, we're doing Ask an Astronomer.
Ask an Astronomer, yep.
Yes, which we haven't done one of those in a while. And so it'll be a great time to send us in all of your questions. And we can hopefully answer them. We'll see. Might be Stump an Astronomer. We'll find out. Mm-hmm. But yeah, so lots of fun stuff coming up. We've got those camps that are starting up soon, and it's going to be a great summer. So yeah, thanks everyone for joining us. We hope you have a wonderful rest of your day, and hope to see you again in the future. So bye everyone.